Hello, this is Millard for Real-Time Rendering Assignment 1 on implementing various lighting models. So first of all, a bit about the code that I use. I start by including ImGUI, I use glfw and GLAD. I've implemented my own model reading, camera, and shader header files that implement their respective components, and I use glm for my math calculations. The start of the code is very much as you would expect for an OpenGL application. I have various camera parameters, various window parameters, model parameters, and so on. I configure my window using glfw, I set it to full screen, then I read in my shaders, I read in my model, which is actually a teapot model, the Utah teapot. Then I fine-tune my camera, set up my ImGUI window, and these parameters all pertain to the 4 lighting models that I've implemented for this assignment. And I have sliders inside my OpenGL window that fine-tune some of them in real time so that the lighting effects can be seen on the models as they rotate by changing the value of the slider corresponding to each field. So this is the render loop. Inside the render loop, I just configure my ImGUI window. I use my shaders to set the various uniforms that the sliders have set in the previous loop. And then very straightforward, positioning my models, rotating them. Rod Z was actually for the plane model, but Rod Y is the 20 degree per second rotation of the teapots. I then implement the Lambertian model, the Phong model, the Cook-Torrance model, and the Blinn model, all of which are implemented in the same shader file, but I set this lighting ID in the shader to determine which model to render the same teapot model with. And then this is just setting up my ImGUI. I then have my handling for my camera, WSD, Q and E for up and down, followed by my mouse callback and scroll callback functions. In the shaders, so this is the fragment shader. The vertex shader is very straightforward. It just takes in the projection matrix, view matrix, model matrix. Let me actually just open the vertex shader. Yeah, so it's a very standard vertex shader. I set the position, the vertex position, the vertex normal. These are uniforms that are set at the start of the render loop. I also give it the position of the light and the view position, the view matrix of the camera in the world space. And I output these corresponding vector 3s, which are used in the fragment shader. So coming to the fragment shader, I have an ambient light element, I have a color for the model, and I have a light color. And these are used to combine the effects of the ambient light, the specular light, and the diffuse light. So as I said, this lighting ID is used to determine which lighting approach is used in the fragment shader. So starting with the Lambertian, which will appear in the top left of my demonstration. It's a very straightforward implementation. I then implement the Phong, which includes the specular components. I calculate them individually and then add them up. I then implement the Cook-Torrance lighting. This was quite a complicated implementation, so I did use ChatGPT to assist in formulating these various variables. But the same applies. Calculate the ambient, diffuse, and specular components and add them up. And then finally the Blinn model. So those are my 4 implementations. They appear alongside one another in my demonstration, as I will show you now. So the camera has basically WASD, Q and E functionality, and then here's my ImGUI. So to start, I can move the light around. That's probably the most clear for the demonstration. You can change the ambient lighting. It does get a bit overwhelming, so I'm going to keep it very low for this demonstration. The Fresnel reflectance, you can see as I tweak that, the Cook-Torrance model in the bottom left, the light becomes a bit more scattered along the surface. It becomes shinier in a greater surface area. So I'm actually going to keep that quite high, I think. And then the roughness, that also pertains only to the Cook-Torrance model. But if I change that, you see it'll become a bit of a more matty clay-like surface. But if I turn it down, the light will be very concentrated and the surface becomes very shiny. And then finally, the specular component, which will affect the Phong model and the Blinn model. If I turn that down, you see the light hits the surface and scatters far more. Whereas if I turn it up, it becomes a far more concentrated dot in both instances, giving the teapot a much shinier appearance. So this is the Lambertian model. None of these except for the light position and the ambient light will affect it. It simply implements the cosine rule and scatters light in all directions equally. But the other ones have their respective parameters that tweak them. The Fresnel for the Phong and the Fresnel for the Cook-Torrance model, the roughness for the Cook-Torrance model, and the specular for the Phong model and the Blinn model. Thank you.